Hi, this is an example problem from Chapter 20. This is on AC circuits, resistance and power dissipation. Pause for a moment and read the question. Okay, so we can see a picture of what such a circuit would look like here. These light bulbs are resistors, effectively, and they have been attached to a AC generator which provides a 120 volt RMS voltage. The bulbs have different power ratings, as you can see. Let's look at part A. Calculate the resistance of each bulb and determine which has the greater resistance. Let's look at the 75 watt bulb first. And so we're dealing with AC circuits here, but I want to point out that we use the same exact equations as we did for DC circuits with AC circuits. And so Ohm's law is still the same. We just use RMS values of V and I. If we use the RMS values of V and I, we can calculate the average power, and it's important that we have to use the RMS values to get the average power. So we have the same equations as before. We're going to try to calculate the resistance. And we've got these two equations, right? These can always be used together and substituted in for one another. So let's see here. The resistance R from Ohm's law, that's going to be equal to the RMS voltage divided by the RMS current. Now, what do we know? We know the voltage, good. We don't know the current, though. We do know the power, P. What can we do? Well, let's use the other equation and do some substitution there. So, using this equation, I know what the power is, I don't know what I is. Let's rewrite that real quick. So, I, RMS from the power equation, it's going to be equal to the average power divided by VRMS. Let's substitute that in. So this gives us another way to look at this. And in fact, if we go back, notice how by doing substitution we can get these various equations for the average power. Any of these three you can use. All right, so for the 75 watt, we're going to have 120 volts squared divided by 75 watts. And I'm in SI units, so I know I should be getting the value for resistance here. It should be in ohms, and when we put this into the calculator, we get a value of 192 ohms. So there's for our 75 watt bulb. Let's try the same thing for the 150 watt bulb. Jump straight to the equation. $150 watts this time. Well, we can see it's going to be half as much, and that comes out to 96 ohms. That's the 150 watt bulb. So, which one has the greater resistance? Greater resistance is for the bulb with the lower amount of power. And that makes sense because it has a higher resistance. That means for a given RMS voltage, less current will flow because there's greater resistance, and therefore less power will be dissipated in the resistor. Let's look at part B. Calculate the RMS current drawn by the 75 watt and the 150 watt bulbs if they're operated at the specified voltage. So we're going to go ahead and operate these at 120 VRMS. This is what we have coming out of the outlets at the United States here. And let's see what the RMS voltage is. Well, I can use Ohm's law just like before right here. We're going to go ahead and calculate I. So using Ohm's law to calculate I, that's going to be I RMS is equal to VRMS divided by R. Now for the 75 watt bulb, well, we've got 120 volts, and the resistance for the 75 watt bulb, 192 ohms. Putting that into the calculator, we get a value equal to 0.625, and I know that I'm going to end up with amps here because I'm in SI units. So here's our value for the current that flows through. This is for the 75 watt bulb. Let's do the same thing for the 150 watt bulb. Same equation from Ohm's law. Same voltage we've plugged it into, standard in the United States. And in this case, we've got the lower resistance, 96 ohms for the higher power bulb. And, well, we're dividing by a smaller number, factor 2. This is going to go ahead and increase the current by a factor of 2. And so we get an answer equal to 1.25 amps. So as we expect, a larger current in the bulb with the higher power rating. Let's look at part C. So we're talking about AC current, and of course AC current, as the sine wave shows us here, it implies that the current doesn't just go in one direction, but it just oscillates back and forth. So it's going to go in this way, and then it's going to go that way. And so back and forth, the current is just oscillating back and forth the entire time with some frequency. In the United States here, it's 60 hertz. But we're going to go ahead and use the RMS values to calculate what are the peak values, right? So it's oscillating between a high and a high value, and then it goes down to a negative value of that peak value, and then back up to that top value. The RMS value is kind of an average. What are the peak values, the highest value that it gets during its cycle? Well, there's a simple equation that we can use to relate that. To relate the peak values to the RMS values. Peak is higher, RMS is smaller, so if you know what the peak value is, you divide by root 2, you get the RMS value, whether for current or for voltage. In our case, we want to find the peak values. So to get V peak, as we write like this, that's larger than the RMS value. So based on that equation, we're going to be multiplying square root of 2 times V RMS. That'll make it bigger than the RMS value, right? Root 2 multiplied by 120 volts is equal to a peak value of about 170 volts. Now to do the RMS current here for the two bulbs, we're going to go ahead and use the same thing we did just to convert from RMS value to peak value. So let's start with the 75 watt bulb. And if I want to get the peak current there, I'm going to take the RMS current and multiply by root 2. And so we're going to have root 2 multiplied by 0.625 amps. That gives us a peak current of about 0.88 amps for the 75 watt bulb. For the 150 watt bulb, it's going to be the exact same thing, except we're going to put in the other value for the 150 watt bulb, which is 1.25 amps. And that is going to give us a value equal to 1.77 about. Peak current. So what does that mean? Well, just to quickly think about it, if we go ahead and plot the voltage as a function of time here, what the peak value means is that you're going to, let's take the 75 watt, you're going to have a peak value of Actually, I'm just doing the voltage. So 170 and minus 170. So we're looking at the RMS voltage. That means that it's going to cycle between these two values. It goes back and forth, back and forth. Whereas the RMS value, 120, that is a type of average of that voltage.